Okay, hello everyone. Let's just wait a couple of minutes just in case anyone else wants to join. I don't think I've sent emails out, so I'm gonna see if I can do that now. In case you know anyone, just let them know that we're about to start. Okay, I'll try to add your emails next time for the exercises and recitation. That way you'll get a notification when the meeting's about to start. But it should be Mondays and Thursdays at 5 p.m. Okay, so I'm gonna skim over the questions and answers. They're pretty much the same as the recitation. So if you have any questions, just stop me and let me know. Okay. So can you all see my screen, by the way? Can you see the assignment? Can you hear me? Hello. Okay, good. Okay, so first problem is pretty easy. So what are these which of these are propositions and what are their truth value? So are they true or are they false? So the North Pole is hot. Well, if it's a proposition, then it should either be something that's true or false. The North Pole is hot. That's something that's either going to be true or false. And in our case, it's going to be false because it's pretty cold down there. What is your AUB ID? You answer that with an actual number that's not a yes or no. I spent all my money on books. Well, that's either going to be true or false. So it is a proposition, but what is the truth value? Where it depends. So if we scroll down to the answers, we can see that Part A was indeed a proposition, part B was not. Part C, it is. Well, if it's true if it's true for you, if you spent all your money on books, then it's true, false otherwise. So with these sort of questions, it's not really a trick questions, it's more of use your logic. Like if you ask yourself, what was I supposed to write? Was I supposed to write true or false? Well, you see now, it just kind of depends. If you wrote both of them, like if you wrote both true or false, it depends on the scenario, that's also true. If you wrote only one of them, that's also fine, as long as you just like explain what's your answer. Stop smoking and start exercising. Not a proposition, it's an order. Makes sense. And the not and that we learned about, which is just not. And so it's like the opposite of and. Are the primitive components of CPUs? Well, it's either going to be true or it's either going to be false. So it's a proposition. If you didn't know whether it was yes or no, you could have Googled it, and it is yes. Like they are primitive components of CPUs, NANDs, all of the logics that we've taken, like and, or, even XOR, which is this thing, a plus with a circle. All of these are like primitive components of CPUs. It's how this whole thing is put up together. So any problem with part 1 or exercise 1? Okay. Again, if there's any trouble with my voice, if you can't hear me clearly, or there's any question you didn't understand, stop me at any time. Exercise 2. Let E, I, H, and A be these propositions. Propositions. So are they going to be true or false? E, electrical power is on. So not E would mean that the power is off. I, you have ishtirak, you have electricity from the motor. T, temperature is above 40 Celsius, and A, you can use the AC. Okay, just a bunch of information. Write these propositions using Okay, so we have a bunch of propositions downstairs. We want to write them using these. So electrical power is off, and move away, and you don't have ishtirak. Electrical power is off, so between the brackets they told us it's not E. And you don't have ishtirak, so not I. So just not E and not I. No implication yet, we're just stating some facts. Again, if you're just joining in, we're at exercise 2. If there's anything you don't understand, I'm skimming through the questions and answers, so if there's anything you don't understand or you don't hear me properly, please stop me. Part B. You can use the AC whenever the electrical power is on. So with keywords like whenever and if, and kind of like conditional statements, that's when we're probably going to have an implication. So you can use the AC whenever the electrical power is on. See how I wrote if on top of whenever? Because this is like saying if the electrical power is on, then you can use the AC. So that's why it's E implies A. Remember, this is E. And this is A. So E implies A. If you did the formative quiz, there was a question, I think it was question number 5, which was, I thought it was the most fun, because in question 5, you were given a question which was kind of like part B. You can use something whenever. So the keyword in question 5 was you had the word whenever. And you were told to write the contrapositive. So the contrapositive would be, in this case, not A implies not E. But in order for you to get the contrapositive correctly, you first had to write the statement, which is E implies A, before doing the contrapositive. If you had tried to do the contrapositive directly, and I'm writing contrapositive in quotes because it isn't really contrapositive. So if you try to do it directly without writing first and the statement is E implies A, you would have gotten, let's say, not E implies not A, which isn't a contrapositive. So question 5 was interesting because it sort of had this trick question where before trying to write the contrapositive directly, you had to first write the original statement, what it was. So hopefully you did the formative quiz and you did it right. Moving on. If you don't, okay, so we already started with if. This might imply we're going to have an implication. If you don't have electricity, but you have ishtirak and the temperature is above 40, then. So if all these guys before, then you can do this guy. So I think that before they're just a bunch of facts altogether. You don't have electricity, not E. You have ishtirak, that's I. And the temperature is above 40 for some reason, that was T. All of these together are going to give you AC and yeah, not E and I and T give you A. This is the easiest way for implication, if then. Okay.
That
Yeah. What's up?
B, why isn't it A implies B? A implies E.
Why isn't it not A implies E?
Yes.
Well, tell me, if you use the AC, does that mean the electrical power is on? Like what you're telling me is why is it not A implies E? If A is saying you can use the AC, I'm asking you, if you can use the AC, does that mean that your electricity is on? Like Jay الكهرباء, the normal electricity? No, no, it could be the اشتراك. اشتراك could be here.
Yes.
Yeah. And so so that's one thing. And the other thing, you can think of whenever as if it's kind of like saying if. Whenever the electrical power is on, or if the electrical power is on. So this is your condition. And if your condition is satisfied, then the result will happen, which is you can use the AC.
Okay, then the condition we put it first.
Usually we'd put it first. Like if you read part C, it's doing it the way you'd normally do it. If condition, then result. But in part B, it's done in reverse. First the result, then the condition. This is where you have to use your logic to actually get how the implication should be done. Okay?
Okay, thank you.
Anytime. Okay, part D. Temperature is above 40. Go away. I don't know if you guys see this, but sometimes when my cursor is at the bottom of the page, this black box comes up and I can't see. And I don't want to scroll down because we'll see the answer. Temperature is above 40, and you can use the AC only if the electrical power is on. Temperature is above above 40. So this is your T. And, okay, so it's kind of like it's its own statement. T is something, and they're building a whole nother proposition or formula. And you can use the blah only if the electrical power is on. Let me scroll down. Or you have ishtirak. Only if. So again, like part B, the condition is being written at the end. Or what? Let me see that. Actually, let's check the answer for this one. Temperature is above 40, so yeah, that's the first part, T. And you can use the AC only if the electrical power is on or you have ishtirak. What do you guys think? Should it be A implies E or I? Or should it be like this? E or I implies A. So 1 if it's the first one, 2 if it's the second. Okay, I see none of you have answered. So you can use the AC only if the electrical power is on or you have اشتراك. Well, the reason why it's number 2, well, let's say it is number 1. So the electrical power is on or you have اشتراك. Does that mean you can use the AC? Well, no, because what if the AC is broken? Right? Or what if you don't have an AC at all, so you can't use the AC? But they're telling you you can only use the AC, so you can use the AC only if the electrical power is on or you have اشتراك. So if you have both of these conditions together, then that should give you that you could use the AC. If it sounds confusing, it's a little bit confusing. Party. To be able to use the AC, it is necessary but not sufficient that the temperature is above 40. And that's those are another 2 interesting words, necessary and sufficient. So let's see what they wrote. To be able to use this AC, it is necessary but not sufficient that the temperature is above 40. This part gives you the first one. We mentioned in the recitation, when we have alpha implies beta, we say that beta is a necessary condition for alpha. So when we say to be able to use the AC, it is necessary that the temperature is above 40. Well, the necessary is the temperature and the using is A. So that's where we get A implies T. It's literally just applying the rule. Alpha implies beta. Beta is a necessary condition for alpha. So they tell you to be able to use the AC, it is necessary that the temperature is above 40. So that's where A implies T comes in. But then they say, but not sufficient. So another thing is alpha implies beta is written like this. So alpha is sufficient for beta to be true. So when they tell you to be able to use the AC is not sufficient that the temperature is above 40. So forget the not, first of all. If we read it just as to use the AC, it is sufficient that the temperature is above 40. To use the AC, it is sufficient that the temperature is above 40. So the temperature being above 40 is sufficient for A. That's where T implies A comes in. But we're saying it's not sufficient. So all of the implication is put in a big no, not. Make sense? Does anybody have a problem with part E? Okay. So great. This idea is important. If it's still a bit fuzzy, you can revise the recorded recitation where I go into a lot of details and this alpha implies beta. think that this is the last part, F. Having the electrical power on and the temperature above 40 is necessary and sufficient to be able to use the AC. If you just apply what I said for part E, first of all, having the temperature on and the temperature, the electrical power on and temperature above 40, this is just E and T. We're saying it's both necessary and sufficient. So there's this and there's this. There's no not from part E to use the AC, which is A. So you have both ways, you get the equivalence. Instead of saying is necessary and sufficient, we could have simply said is equivalent to. Or we could have said if then and then said if then again the other way around to get both implications. I'm just saying there's a whole bunch of different ways to do this. So the more you're used to all these different terms, the better you're gonna be at it. Okay. Exercise 3. If you have any problem with exercise 2, you should stop me now before moving on. So similarly, we're going to be translating, but this time it's going to be the other way around. From logic, from discrete structures, from propositions, formulae, all that, back to English. We have G, S, and V. You are blah, 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 the signal is strong, you can make whatever. Express each of these propositions as an English statement. Not G implies not V. With implication, the easiest way to do this is just to say if then, and plug in here the first part. And on the other side, you can plug beta. So alpha here is just not G. So you can say if you are not subscribed to 4G internet over your phone, then you can't make high quality video calls. This is like, I feel the simplest way to say it, but there might be another way. Let's see how they wrote it. Okay, they're just the same. If you are not subscribed, then you can't make high quality. But it could have been done in a like something like this, or oh no, actually no, this is equivalence. Like all of the implications that we did before, it could have been done like that. Part B. Not V and G implies not S. So same thing. If not V and G, then not S. And you just plug it in. Not V is you can't make high quality video calls, and you are subscribed, then not S. The structure of the sentence, what you actually write, doesn't really matter if it makes sense or not. You just care that the translation is correct. So you cannot make high video calls, even though you are subscribed to 4G net. So that's a different way of saying and. What was this? G. It's just a different way of saying that. So it's cool to test things out. Then the signal is not strong. Part C. Again, stop me if you have a question. G and S implies V. You are subscribed, blah, blah, blah. Okay, so I'm just gonna run through these. Like I think we get the structure of the if then. You can make video calls if you are subscribed to and this. So they wrote it in reverse. This is the result. You can make if or whenever. Like these keywords, you can pull them out, and this is your condition. So we're writing the statement in reverse. If we wanted to do the contrapositive of this, you'd first have to translate it to this guy, and then you say not V implies not G and S. The reason I keep mentioning contrapositive and not inverse and converse so much because as I hope you know, the truth value of the inverse and converse is not necessarily the same as the original, but the contrapositive is. What does that mean? Let's say all of this statement is true, then all of this statement is also going to be true. If all of this is false, then all of this is also going to be false. However, the inverse and converse doesn't necessarily have to be the same. The contrapositive is equivalence, but the inverse and converse, they could be whatever. Okay, two more. Actually, okay. Just implication that we already know, even if blah, 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 then blah, blah, blah. Just another way of writing the implication. I'm interested more of the equivalence since it's new. I would say V is equivalent to G and S, for example. You can have, oh yeah, this is even nicer. If and only if. Again, I mentioned it in the recitation. The equivalence, or this, and this, all of them are the same. These guys are equivalent, literally, they're equivalent to saying if and only if. So going this way and going this way. Okay, exercise 4. The contrapositive, converse, and inverse. Let's do one of them because I think there's like 3 or 4. Let's do one of them. Then if you guys have any problem with the other 2 parts, you can let me know. State the contrapositive, converse, inverse of each of the following statements. Start by specifying P and Q for the original statement. So just like the recitation where we used, I think, C and something else, I don't remember. So P and Q are usually what we'd use, but you could use X, Y, R. It's just a variable name, a proposition. But try to use whatever the professor uses in his lectures, just so we use like familiar terminologies. To be healthy, eat a banana daily. To be healthy, eat a banana daily. Let's see what they decided to make it. So P is gonna be eat a banana. Q is stay healthy. So it's P implies Q. To be healthy, you need to eat a banana daily. So if you eat a banana daily, what should that tell you about yourself? It should tell you that you are healthy. Again, this whole statement, it's either going to be true or false. It's a proposition. It's either going to be true or false. And with the contrapositive, it's going to have the same truth value. All right, I'm saying this now because there's an important idea to mention later. Or maybe to mention right now. So what's the contrapositive? Not Q implies not P. If you are not healthy, go away black box, then you don't eat a banana daily. If you are not healthy, then you don't eat a banana daily. Not healthy, you're not eating a banana. As a translation, as a contrapositive, it makes sense. Now, some of you might say, there might be other reasons why you are not healthy. Like you could be eating bananas, but you have another disease, or you're sick, or you have a cold. So this statement, it doesn't make sense. Like if you are not healthy, then you don't eat a banana daily. You could be eating bananas daily, but you're still sick. You're right, logically, but remember that P implies Q is going to have the same truth value as the contrapositive. So assume that it is true. Assume that it is true for now. If you eat a banana daily, then you are healthy. This is like a rule for you. If you eat a banana daily, then you are going to be healthy. No matter what. No matter what. So So if I go by that rule, if I go by that logic, and I see that you are not healthy, then I could only conclude that you are not eating a banana daily. Because assume that this is like a law, it's a rule. You eat a banana daily, you're gonna be healthy. That's a rule. So the contrapositive is saying, if I see that you're not healthy, then the only logical conclusion is that you're not eating a banana daily. Okay? But we kind of know that the truth value is gonna be false and false for both of them. But while solving it's easier to just assume in your head that it is true, so you can work out how the contrapositive works. That was a lot of things to say. If you have any problem with what I just said, stop me. Converse. If you are healthy, then you eat a banana daily. If you remember the converse, it's kind of like you're just flipping the letters, the variables, the propositions. If you are healthy, then you eat a banana daily. Humor me just a bit. If we go by this law, which we just assume that it's true, that if you if you eat a banana daily, then you are healthy. The converse isn't necessarily true, because you could be healthy because you eat an apple. Okay? You could be eating an apple that makes you also healthy. That's why I'm trying to say assume that the original statement is always true. Because if we assume that this is true, then when we say the converse, hey, you are healthy, then you eat a banana daily, that might not be the case. If you eat a banana daily, you're gonna be healthy. But if you are healthy, you could be doing other stuff. You could be doing yoga, who knows? So in the realm where we assume that P implies Q is true, the converse does not necessarily have the same truth value. It could, but it not necessarily. Inverse, not P implies not Q. If you don't eat a banana daily, then you are not healthy. Don't eat a banana daily. Not healthy. Okay. Good. So that's how we do that. Part B and part C. Is there a part D? No. So same idea. You break it down into P and Q, and you keep going. The statement could have had two conditions, right? It could have been, I go swimming whenever it is sunny, and let's say sunny and clear. Sunny already means clear weather. And I like peanuts. Okay, so you could have had here two conditions. Let's say this is E. Then you'd have to break it down into statements. P, Q, and E, and then you say, if it is sunny and I like peanuts, then I'm gonna go swimming. I'm just saying it. If you don't just assume it's always gonna be two propositions. P implies Q. It could be a slightly more complicated, but you could just assume that P and E is just your like one big alpha. You're still gonna say for the contrapositive, not beta implies not alpha, but alpha just happens to be two propositions, P and E. Okay, try to be versatile is what I'm saying. Okay, does anybody have problem with part B or part C before we move on? Okay, if you do and you're not gonna talk now, just send me a message and I'll answer you. But please, if you have problem with any of the parts, talk now. This is the whole purpose of this session. Okay, exercise 5 should be quick. Determine if it's inclusive, exclusive, or intended. To be honest, I'm not sure at the moment what they mean by intended. Let's see if one of the answers is intended. If it's not, I'll search and let you know. If anybody knows what intended means, please let us know. So having experience with Python or Java is required. Well, if you're applying for a job and they tell you we need you to have either experience in Python or Java, if you say I have experience in both, they're not going to say, oh no, sorry, we only want one of those things, exclusively one of those things, which is why it's an inclusive or. Includes soup or salad. Lunch includes soup or salad. I feel this could also be inclusive. Okay, exactly. So, exclusive or. You can choose to have a salad or a soup for lunch, but not both. I see. Okay, that wasn't really clear. See, again, this is one of those things where I would have accepted you either saying inclusive or exclusive depending on how you explain it. So the way here they explain it, exclusive or, since, hey, if you're ordering lunch and there's an option where you can either choose salad or a soup, but not both. Like there could be some offer on the menu. It's a big meal and you can either choose soup or salad. Kind of like those options where you can either choose tabbouleh or salata or fattoush and all of that stuff. So if you explain it in that way, then I'll understand it's exclusive. The reason why I thought it was inclusive is because, hey, I'm at a restaurant and I want to order both of them. Nobody can tell me no. So it works both ways. If you have these questions where you're not sure if it's this or this, explain your answer, and if your explanation makes sense, then your answer is going to make sense. See, a proposition is either true or false. I think we did that. Yeah, we did that, I think, in the recitation. And okay. Exclusive, yeah, definitely. I'm not sure if we mentioned it in this assignment, but we did say that P can either be true or false, but only one of them. Like it's either true or false. It's literally exclusive or. It can't be both at the same time. It can't be maybe. You can solve all the assignments or you will do bad on the exams. You can solve all the assignments or you will do bad on the exams. What are you? Inclusive. Go away, black box. You might solve all the assignments and still do bad on the exams. Okay. So this is like somebody telling you, hey, two things can happen. You can either solve all of your assignments and do well on the exam, or you will do bad in the exam. This is someone telling you it's either this is going to happen or this is going to happen. But no, you could be unfortunate and be working hard and solving all the assignments, and you did bad on the exam as well. Hopefully that won't happen, but it is a possibility. Is that all of it? Yeah. We didn't get a part where it said intended. By any chance, does anybody of you know if the professor mentioned this thing in class? Intended? Let me. Intended logic. Intended interpretation. I'm Googling it, by the way. Many formal languages are associated with a particular interpretation that is used to motivate them. Cool. While the intended interpretation can have okay. I think they mean implication. I think that might be it. No, it's like implication. As an English word, I'm not completely convinced, but this could mean an implication. I'll get back to you with a better answer for this. Any problem with exercise 5? Okay. 6. Construct a truth table. I think, does anybody have problem with exercise 6 with the truth tables? Because I'm not gonna waste that time on this. It's pretty simple idea. Here, like for example, remember what we said, if you have, like here, you have 3 propositions. So P, Q, and R. So 2, 2, 2. I mean that P can either be true or false. So the total number of possible assignments is gonna be 8. So for P, you write 4 trues, then 4 falses. For Q, you write 2, 2, 2, 2. Then for R, 1, 1, 1, 1, alternating. This way you write all the possible assignments. If you had another guy, W, then you'd write 8 trues, then 8 falses. This might be the 3rd time I've said this, so I could understand if you're bored with it. For P, 4 true, 4 falses, then 4 trues, then 4 falses. The reason I keep repeating this so much because some students will still randomly try to fill this truth table, and it's a real hard time to correct. So try to write it in this format. If you didn't for the first practice set, do it for the rest of them. Okay, so far so good. Okay, so use equivalence rule. I think we're down to exercise 7 and 8. They're both the same idea where you want to use equivalence rules. But for 7, we want to prove that it's a contradiction. For 8, we want to prove that it's a tautology. Contradiction means you want to prove that this is equivalent to false. Okay. How it would be nice for you to solve it and preferable is like this. Whatever equivalence rule you do use, you write it here on the right. So you move from here to here by using De Morgan's law, then from here to here by using double negation. Do you need all these details? It would be nice. Like for in the written exams, what we'd usually say for the first one, write all the steps. Then for the second one, you might not write all the steps, just so that we get that you understand all of it. So you could do that for the assignments. Like for the first one, write every single step. For the rest, you could skip a few, as long as it's nothing major. So step 1 is De Morgan's law. We have not A, which is P, or B, which is not P and Q. De Morgan's law just says not A and not B. You get this and this. Double negation, you can remove the not. And here you can already see that it's over. You have not P and you have P. So it's going to give you false and something, which is false. But baby steps, in order to reach that, you'd have to use the associative laws, which basically says you can move these brackets from here to here. False and Q, domination laws says it's just going to be false, which is false and anything is going to be false. Same idea here. Same idea. Usually when you have implications, it's nice to get rid of them right away. So here I think they skipped a step. So first you do sorry, not, did I say negation? I meant implication. So we have alpha implies beta. It's equivalent to not alpha or beta. So here they said R implies not S is going to be equivalent to not R or not S. And then they entered the negation right away. That's why you got R and S. Then they did the Morgans for this guy, and they got not R and not S. And again, just like before, it's already done from the second line. You can see you have here R and you have not R. So it's done because it's all ands. And similarly, you could do it for S and not S. So they took the long way around where they used associative laws, commutativity, so you can flip order the variables and simply just put S and not S together. So yeah, try to do that. At least say, hey, we have commutativity, so I can flip the propositions together, so I can get S and not S together. So false, and everything is going to be false. Any problem with part 7? Good. Good.
Doctor, we should memorize all of the laws.
They're not a lot. I think they're gonna be maybe 1 or 2 pages. We might have them somewhere. We could put them. If the professor says that the exam is gonna be like open book, like you could use the slides and whatever, then you don't really have to memorize them. You can just have it as a PDF ready. But it's nice, but it'll be easier for you to have them ready on the go. And like it's not really memorization. Like we should have known De Morgan's law from school. It's pretty easy now. Associativity just means you can move the brackets. Commutativity just means that hey, 2 times 3 is the same as 3 times 2. Negation, you see what I mean? Like as you keep using them, it'll be just easier for you to, let's just say understanding them rather than memorizing them.
You mean
Okay.
equivalence propositions? We should memorize them يعني في there's rules.
I don't understand. What do you mean? Yeah, sorry. What was your question? Okay, if you can ask me what your question was. I didn't get the last part you said. Okay, exercise 8. We're gonna do the same thing, but we're gonna be proving that they are tautologies. So as you can see, the trick with proving contradictions was reach something and false. This something could either have ands between them, or it could have ors like A or B or Q, but you'd want them all to be inside the brackets and false. That's the trick to reach contradiction. You simply want to reach false and something. With tautologies, it's different. You want to reach true or something. When you reach true or something, it's going to be true. The something doesn't matter, and that something can either be a disjunction, a junction, which means a bunch of ands, or it could be a disjunction, which means a bunch of ors, or it could be a mix between both of them, as long as they're like here in brackets. How many parts do we have? A, B, and C. Okay, B and C are long. Okay,
دكتور اكيد فينا نعملهم بطريقه اقصر معاك.
yeah, I've said this a lot.
عملنا فيكسد يعني.
Yeah, there's no unique solution. There's no unique solution. And as I've mentioned, the shorter solution is usually better, but shorter in terms of being smart, not shorter in terms of like skipping some important steps. Okay. Like usually if you have De Morgans and you have double negation, it's nice to like split these into 2 different rules. Don't like mix them together. At least again for the first exercise you're solving. So I can get that you understand it. For the second part, if I see you're doing it slightly shorter, I understand at least from the first part that you know what you're doing.
Okay.
Okay, good. Okay, so all of this is going to be your alpha, and this is your beta because or is stronger than implication. So the or will happen before the implication. So what are we going to be doing here? Distributive laws. So what's the distributive laws? They're taking R in common. So if you have R and S, or R and T, you can take R in common, and it'll be like R and S or T. So you can go either way. If you have this, you can go backwards or you can go forwards. The easiest way I try to relate this is using normal math that we know. So if you have 2 times 3 plus 4, it's kind of like saying, hey, 2 times 3, then the plus gets down in the middle, and you have 2 times 4. And I stress it's not exactly the same, but it's nice. It's a nice way to imagine it. Okay, then we do not alpha. So all of this is alpha, beta. Now we do not alpha or beta. Okay, no problem so far. Enter the not, so using De Morgan's, this is A, all of this is B. So not A or not B. The and gets flipped into an or. What do we have? And okay, so a nice thing is now you have all ors. Since you have all ors, we know that or is associative and commutative. You can imagine that all the brackets, you can erase them, and all the propositions, you can flip them together. Actually, no, I'm wrong. This isn't. Yeah, this is not or. This is actually going to become an and. Never mind. Let's just keep going. So what do we do next? Associativity laws. We just move all the brackets together, and yeah. So this S or T is like a proposition P. So you have not P or P. It's true. It's an identity. So it's all done. Okay. Okay. Not a bad way of doing it. Assuming that S or T is just like one propositions, so not P or P. That's a nice way of seeing it. Part B. Okay. Actually I skimmed over the solutions. I think part B and C are like exactly the same idea. So I'm gonna explain B in detail, and you can let me know if you have any problem with part C. So we're almost done, don't worry. Okay, again, all of this is alpha, and this is beta. Step 1, before doing your big implication, get rid of the smaller implications. So not R or not S or T, and this. Now you can do your big not alpha or beta. So not all of this or this. Entering De Morgan's law, and where do I want to stop? Here. If you have any problem before this line, let me know. We just switched the implication to what their equivalent, and we did De Morgan's. So we reached this step. It's nice to remember that we're trying to prove that this is a tautology. So if you notice, you have R and you have not R. You have not S and S. You have not T and T. So you have all the proposition and their negations, let's say. You just want to find a way to put them all together. How we can do that? Well, distributive laws come to mind. So if, let's say, you want to get rid of R first, because that's what they're doing. So let's say we want to get rid of R first. So in these scenarios, I assume we're going to have to get rid of them one by one. So first you have to come up with R and not R, say that that's true, and you're done with it. Then you move on to S and move on to T. You might say, hey, you just said you want to reach one of them is true, and then we're done. Yeah, if it's an or. But in this scenario, I feel since we have a bunch of ands, we have to get rid of them one by one because it's gonna be like this. It's gonna be true and something, so you're left with something. And then that something, you break it down into true and a smaller something, and you keep going on till you're just left with true. So associativity and commutativity, what do we? So not R or T is put first for some reason, and next to it is R and not S. Again, assume all of this is just one element A. So not R or T. Or R and not S. So all of this is like one element A, and let's say this is B and C. If we distribute it, like kind of what we did here with the normal mathematics, we're gonna get A or B and A or C. A is this whole thing, which is not R or T, and B is R, so not R, and again, not R or T, or not S, which is C. We have not R and R, so you can use commutativity to put them together. This becomes true, so it goes away. And this is what I was talking about. We have true and something, so we just continue with that something. And what I wrote right now in red, it's up to this step. So here they did the whole distributive thing. Commutativity to get not R and R together. It's true. True or T is going to be true. So that's that. We're still left with this part, but we just keep doing the same thing. So up to the step. If anybody, you haven't followed me so far, please let me know and I'll repeat. So up to this step, what do we have? Actually, I think this is what identity means. Identity just means, I presume, true and something is going to give you that something. So I may have been saying identity wrong before. Before I've been saying that P and not P means identity. P and P or P, sorry, is true, which I think just means it's true. Identity is this thing. True and something is something. Anyway, again, we do the distributive thing, but now it's like three variables. So A or B or C, ORing it with this AND. So it's going to be A or B or C or D. And same thing for the other side. Can we mix them together? We have here S or not S, so that's going to be true. On this side, we have not T or T, so that's going to be true. And we reach it here, true and true, true. Does anybody have a problem with this? The two main ideas were we were doing distribution, and we were trying to find for each proposition its negation to get true. Ask me if there's any problem, because in part C, it's literally exactly the same. Because if you notice, almost like the same. If you notice at, let's say, this part, I believe, you have not P and you have P. You have not Q with its negation Q. You have not R and R. So it's like literally the same. You want to use associativity, distributivity to reach true. So if during the assignment you weren't able to solve, let's say, part B and C, and now you kind of understand B, try to solve C again. Okay. Does anybody have, 6 o'clock right on the dot. Does anybody have any question? Okay. I have a question. It's annoying me. Ask your professor. I'm gonna search for it, but ask your professor what does like intended mean. From my quick Google search, it was saying its implication. It might be that. I'm gonna double check on it. So, any questions? We're done. Okay, we are welcome. Okay, anytime. Okay, hope this was helpful for you. And again, if you have any problems, let me know. We're gonna have our recitation session this Thursday at 5 p.m. But if nobody has any questions, I'm gonna end this meeting. Thank you all for listening and see you Thursday, I hope. Okay. Goodbye, everyone.